Okay, here is warm-up 10.1. I'm going to do a little review. So Grover invests $100 for 9 years in an account that pays 3% interest, and we're going to find the total amount of money at the end of 9 years if it's compounded annually first off, and then quarterly and continuously. So we're going to need different formulas for all of these. For annual compounding, we're going to use this. Our basic exponential growth formula, okay? So the initial amount is going to be the A. My final amount is going to be Y, so I'm solving for Y here. So A is 100, okay? And then my rate is 3%. R is for rate, that's 3%. So I'm going to do the rate, even though it's listed as 3%, I want to write that as a decimal, which would be 0.03. So I'm going to do 1 plus 0.03, so that'd be 1.03, and then the time is 9 years, okay? And then from there, I'm going to simplify. So you want to make sure that you do the exponent before the multiplication, right? You can't multiply before you raise something to an exponent. So I'm going to do 1.03 to the 9th in my calculator here, okay? And then I'm going to multiply that by 100. And that's how much money we should have. And I'm going to round that to the nearest cent. So that's going to be $130.48 roughly. Okay. All right. So compounding quarterly, this means we're going to have 4 compounds per year. When it's annually, we're compounding once per year, so we can use this simpler formula. But when we're compounding some other amount other than once per year, we're going to need a fancier version of that formula that looks like this. So the ends are going to be the number of compounds per year. And you could have actually used this on part A, just the ends would both be 1. And it would simplify to that, actually, if the ends were 1, right? So let's see. I'm going to plug in still 100 for my starting amount. My rate is 3%. Number of compounds per year. If it's quarterly, that means 4 times per year. So the 4 is going to go up there again, and a 9, okay? So I'm going to use my calculator again to sort this out. I'm going to start with this decimal, okay? So I'll start with 0.03 divided by 4, okay? And then I'm going to add 1 to that. So 1.0075 would be the contents of the parentheses there. Next thing I'm going to do is raise this to the 36th. Right? So, because I want to do the exponent before multiplying by 100. So I'm raising this to the 36th. All right, and then the last thing is multiplying by 100. I should wind up with a little bit more money than I had compounding once per year when I compound 4 times per year, because that means we're adding the 3% back into the account 4 times per year as opposed to once per year. Okay, so we end up with $130.86. Not much more, but a little bit more. Okay, and continuously means we're compounding as much as possible all the time. So we have a different formula here when it's continuous, and it looks like this. Okay, all right, so starting amount is 100. Then I've got E, which is a number about 2.718. That's programmed into the calculator. Okay, my rate is still 3%, and my time is 9 years. Okay, so I'm again gonna I'm not gonna raise 100e to that exponent. I'm gonna raise e to the exponent, then multiply by 100. All of these, the last thing you're doing is multiplying by 100. Okay, so I'm gonna sort out what 0.03 times 9 is. That's 0.27. Okay, so I'm gonna do e raised to the 0.27. So there's 2 places where the E button is. It's if you can hit second divide to get it, or second ln. If I hit second ln, then it's already raised to an exponent, which is what I want anyways. So e to the 0.27 gives me this number, and then I'll multiply that by 100, and I've got 130. That's actually going to round up to 131.00 if I'm going to the nearest cent, right? All right, and you can see, yeah, we get more money, just a little bit more, but we get a little bit more the more you compound. Okay. All right, next up, let's solve this for x. We're going to round to the nearest hundredth. So I want to isolate the x as much as possible. So I can get rid of the 5 by subtracting 5 from both sides. So now I've got 3 to the x minus 1 equals 24. Sometimes I see people try to divide by 3, but that's not going to work. Then I would have 3 to the x minus 1 over 3. That's not going to isolate the x minus 1. Okay, I'm going to have to put this in log form. And you want to put this, you want to make sure that you simplify as much as possible by adding, subtracting, multiplying, dividing before you put anything into log form. So you wouldn't want to put the original equation in the log form because there's nowhere to put the 5 if you do. Okay, so now that I've got it like this, my base is 3. All right. The exponent is going to get isolated, so the x minus 1 gets isolated. That's what I want to happen. And then the 24 goes right here. So the purpose of log form is that it isolates exponents, right? And that's the only way I can isolate that exponent in that position. Okay. Now the left side of this, I'm going to simplify with my calculator. You could add 1 to both sides, but beware, it's not going to be log base 3 of 25 because the 24 is inside this log and the 1 would just be added on afterwards. So I'm going to simplify this left side first, and I'm going to have to do change of base on my calculator. So this is going to be log of 24, close the parentheses, divided by log of 3. I'm using the change of base formula there. That's how I'd put in log base 3 of 24. So then this is about 2.89, and I want to add 1 to that. So I'm going to get about 3.89. Right, when I add 1 to that. All right, so there's that one. I'm going to use the same kind of strategy on this next one because I've got an x in my exponent and I'm going to have to get it out of there. So at some point I'm going to have to put this in log form. But before I do that, I'm going to add 3 to both sides. So e to the x plus 2 then will equal 44. Okay? And now only thing I can do, I can't use square roots. That's not going to do me any good, or any kind of roots. I'm going to have to put this in log form. So my base is e. All right, the 44 is going to be the contents of the log, and then the x plus 2 goes over here. All right, and log base e, that's our natural log. So that's a cursive ln there. Okay, and I'm going to put this left side in my calculator. So there's that ln button. Clear this out. Natural log of 44 is about 3.78. And then subtract 2 from that to solve for x. And I'm going to get about 1.78. Okay, and that's approximate my answer there, right? Okay, that's it for this warm-up, and I'll see you next time.